Today we have with us Avishai Henik. Avi, that's the way we call him because he's a very good friend of us, is now an emeritus professor at the Ben Gurion University of the Negev in Israel. And he was educated, I have to say that, because he studied and is one PhD student of the only Nobel Prize that we have in psychology, which is Dan Kahneman. And he also was a postdoc with Mike Posner. So he had the best influences one can have to be what he is today, one of the leading figures in Israel, in Europe, and very known all around the world. Well, we are very happy to have you with us. And we know that you are develop a very interdisciplinary type of research because you have been the director of many different lines of research in Israel. Now, one thing that really impresses me is that you that have been always working on basic research, now you seem to have a very interest in applying, so to speak, that knowledge to different fields of psychology. In particular, I would like to ask you one question. Your research in attention, do you think that can be applied to help people and really to resolve some of the practical problems that the clinic might have?
I think the answer is yes. We are far from implying everything, but for example, if we talk about self-regulation, we used very simple training with the flanker task. In the flanker task, you are presented with, say, an arrow in the center, and you are asked to decide if it's if it points to the right or to the left, and there are arrows around it that can point to the same side or to the different side, so it's either congruent or incongruent. And of course, in the incongruent case, you have to ignore the arrows that are pointing in the different direction. And this is a very simple task, but still, if you train people with 80% incongruent trials, it turns out that they learn somehow to inhibit responses in other cases. For example, it reduces rumination, which is a predictor of depression. Also, in another study, one of my students showed that training with this flanker task may enable one to deactivate the amygdala, a lower brain structure that is related to self-regulation or to emotions. So this is real. And I believe that we can do it, but it becomes a little bit more difficult when we try to use other tasks and to, for example, turn this into a game that people like, because flanker, after all, is not a very interesting task. So if you try to use a different task or to take this into the game or video games area, there is a difficulty to really transfer the knowledge. It is not very simple. It's not as simple as we would like to think. In another line of thinking about this, it is very hard to get the industry, at least this is my experience in Israel, the industry of various startup companies to see the importance of psychology and to implement psychology into their various enterprises or to use psychologists. But I do believe that it will come, and eventually they'll see the importance of psychology and will use psychologists in their various enterprises. And I think that we'll be able to really help people.
Thank you. My second question has to do with a problem that we psychologists have studied for a long time. We've been interested in habit. And somehow, within psychology, we have distinguished between automatic and controlled processes. Do you think that this distinction still has any value, or do you think that we have to change it?
I think the distinction has a value, but I think it should be more refined. Mike Posner suggested at the time to think of automatic processes as being similar to reflex. When people think of reflex, they usually think of something that cannot be changed. But this is only in principle, because all the reflex arches have connections to higher brain structures. So in principle, they can be changed, they can be affected. Even the knee-jerk reflex can be modulated by higher up processes. So I think that the way we should think about it is a more refined, that is, things can be automatic, they can be less automatic, it can be graded. Also, another way to think of automatic processes is that they are kind of circuits that were designed to deal with a specific problem. And actually, development occurs when they become accessible to other systems. So in this case, we have something that was automatic, completely encapsulated. And now it becomes accessible to other systems. So it becomes not very automatic, because now it serves in for other purposes, but by other systems and so on. So this is another way to think about it.
Thank you very much. You have developed also a very interesting line of research on synesthesia. Could you please first explain to us what this condition is, and then will you think that this phenomenon may help to understand the working of the brain in somehow?
So, synesthesia, the word means blending of senses. So these are people who see colors when they hear music, or numbers are connected to colors. So 5 is red and 2 is yellow, and so on. It's very interesting. And actually, the person who started the research was Francis Galton. He wrote a paper in 1880 in Nature about numerals who float in space. The beginning of the paper is that he says, well, I want to tell you about a phenomenon that I studied for quite a few years. People see numbers in space, and it is reliable and very interesting. Later on, the interest in synesthesia decayed, but in the last 20 years, it kind of was revived. I think the interesting thing about it is that there are connections between areas in the brain, or that are usually do not exist in other cases, or in most normal people. I'm not saying that synesthetes are not normal, but in the regular brain that we are familiar with. But it says something about how this machine works and what connections can happen. And actually, we did some study with Luis Fuentes from Murcia. What we did was a study, we hypnotized students. And basically we Luis taught them that 2 is yellow and 4 is red and so on and so forth. And after hypnosis, they showed the same phenomena as synesthetes. When the hypnosis was over, or the suggestion was over, they went back to not being synesthetes. This led us now to a new project on synesthesia, in which we are trying to actually train people a lot and see if we get the same behavior as synesthete, and also if we do see any brain changes. But this is really new. We just submitted the project. But thinking about the hypnosis, it suggests that actually this should be possible. And it might be related to the issue of training for self-regulation. I mean, so again, you're dealing with training. This is something else, but it all talk about plasticity of the brain. So in this sense, I think it's very interesting.
Well, yes, I'm glad to know about that. Did you know that Luis Fuentes was my first PhD student?
Well, I knew that he was your student. I didn't know that he was the first.
Yes. Well, let me ask you my last question. What are the big questions that you feel, and in general cognitive neuroscience, you think have to resolve in the future?
I think that cognitive psychologists are now, or cognitive neuroscientists are now going more and more into the field, into other fields like clinical psychology. Clinical psychology is a major field, of course, of psychology. This is part of the big questions of psychology were asked in this field. But I think that after quite a few years of experimental work in cognitive psychology, cognitive psychologists are ready to use the tools that they developed in order to think and to study clinical populations. This, in a sense, goes back to Kornbach's suggestion of the aptitude treatment interaction, that actually we should go in this direction. So it took a while, but this is a way, I think this is the way to go. For example, one of my students study OCD, obsessive compulsive disorders, using basically techniques and ideas from cognitive control. He thinks that OCD might be actually a problem in inhibitory control. So he studied this. Another student who is a clinician and now a postdoc in Stanford is working on eating problems and use again methods from cognitive psychology to study eating disorders. So I think this is, first of all, it's very interesting. Second, it's, I think it will be coping with big questions. And it goes back to the first question, I mean, about the contribution of psychology to other fields and so on.
Well, thank you very much for being with us, Javi. Nice to meet you.
Thank you. Thanks a lot for inviting me.